So greetings, sir. In this assignment, we're going to talk about RL's series circuit, which consists of resistors and inductance. And the problem of this assignment is to find the IT, which is current at time. So now, we can solve this problem by applying KVL, which gives us the total EMF equal to VR plus VL, which is voltage across resistance and voltage across inductance. Now, with this formula, we know that VR is equal to IR, but VL is the tedious part. So to find this, we can first apply Faraday's law, which gives us V, which is the EMF of the batteries, equal to d phi, the flux, over dt. Now, since the inductance formula gives us is flux over I, and we're going to transform it into flux equal to Li. Now we sub this Li into this formula, which gives us, so after subbing this formula, we get VL equal to d Li over dt. We're going to transform it into LdI over dt. Now we get this formula, we can put it back to this KVL. So which gives us V equal to TR plus L bracket di over dt. Now with this formula, I'm going to write it equal to I. Now we're going to divide this whole thing into L, which gives us I R over L. And since it's dividing by L, this whole thing will be left in I prime since it's differentiations. Now we're going to rearrange the formula, get I prime plus I times R over L equal to V over L. Now notice that this equation is similar to the linear ODE formula given, which is this one, Pxy equal to Rx. Now, can know that Px is equal to R over L and Rx equal to V over L. And the integrating formula gives us Fx equal to E, integrate of Px dot dx. Now, this E gives us RL dot dt in this instant. So integrate it, should give us E R L, sorry, ERT over L. This is our integrating factor. Now we're going to multiply both sides. So we get d bracket ERT over L times with the I in this instance over dt equal to E of RT over L times with the VL, which is the Rx. So after subbing this Fx into, multiply into this solution, we're going to integrate both sides. So ERT over L multiplied by I integrates of this RT over L multiplied by V over L dot dt. Now this one, after integration, is just left inside what's inside the bracket, and get ERT L multiplied by I equal to, after integrations, go to V over L and L over V after integrating the thing in front of the T. Divide the things in front of the T. And we're going to copy it back, ERT over L and plus C. Now, T over L, I equal to, after multiplying both, we get V over L, RT over L. And I'm sorry for the mistake, this is R, this is L over R, so we get V over R plus C. Now we're going to throw this whole thing into here, so we're going to divide, which gives us IT equal to V R plus C E negative power of negative RT over L. So after getting this equation, we're going to assume that I0 equals 0 since when time at 0, the current flowing in the circuit is 0. So this will give us 0 equal V over R multiplied by exponentials of power of zeros is 1 plus C, which will give us C equal to negative V over R. So the general solution given is IT equal to V over R bracket 1 minus E power of negative RT over L bracket. So after finding the general solution, you know that the graph, we can plot a graph I against T, tau, which is time constant. So time constant, we know that T over tau is the time it takes, is a measure of response time in the first order system. It is the time it takes for a system to reach its final value, which is I, current in this case. So let's assume that V, in this case, a question, V equal to 10V and resistance equal to 5 ohm and L, which is inductance, equal to 2 Henry. Now we can sub the L over R in this formula, which is by reversing the R over L, so we get L over R, and it is equal to 0.4 of time. And the VR, which is I, the maximum current, is equal to 10 over 5 and which is equal to 2 ampere. Now when I is equal to 0, the time is equal to 0. The time equal to 0, the current is equal to 0, since there's no current flowing through. Now, to calculate the percentage, we can use the formula given, the formula found, divide by the Imax, which is this one, divide by 2 times with 100%. We can find the percentage of growth of current of its final current. Now, when t equal to 0, obviously it's 0% of growth, and when t equal to 1 tau, its final value is 63.2%, which is somewhere over here. When t equal to 3 tau, this is getting nearer and nearer to the Imax, which is over here, and so on. As you can see, the graph is going to steady state. Yeah, and to conclude, this application can help us predict how long it takes for current to stabilize in the circuit and to design circuits with predictable time response and help us understand energy stored and transferred in the inductors. And that's all for this assignment. Thank you.